All right, guys, this video notes lesson number 3. The title is determining inverses using composition of functions. Essentially, there's a combination of what we did last Friday and Tuesday. And basically, again, the reason for this, if you know what you're doing, after the first couple examples, you'll be able to probably use this as an answer key to kind of making sure you're on the right track going into our test next week. After a few examples, you may find out you might need some help, further explanation of the video. Please ask me. That's kind of, this video allows me to be in 2 places at once. So what we're going to talk about first is the test to determine if 2 functions are inverses. We kind of alluded to this a little bit at the beginning of class, but the test is essentially this. If we take f of g of x, which we talked about last Friday, and the end result is x, so the result is just a single x. What we're going to do next is we're going to then take g of f of x, and if its end result is also an x, if that occurs both ways there, then that is enough to say yes, those 2 functions are inverses. So this is the test to determine if 2 functions are inverses. The opposite is true as well. If we take the f of g of x or the g of f of x, and either one of them are not equal to x, then we would say they are not inverses. And that's essentially what we're doing in every single one of these problems. It's either a yes, they're inverses, or no, they are not inverses. You do have to have work. You can't just say yes or no. You won't obviously get credit for that. So you do have to have some work for every single problem. The best way to explain this is just to look at some examples. So let's look at example number 1. Again, if we're going too fast, pause it, make sure you get all the notes copied down. All right, so number 1, we want to determine whether those 2 functions given are inverses of one another. So we are simply going to insert the g function in for x of the f function. So instead of x plus 6, we're going to replace that x with all of the g function. And all of the g function is x minus 6 plus 6. And then we just want to simplify that. The negative 6 and the positive 6 are like terms. They cancel out and give us 0. And all we're left with is x. And that's what we're looking for to do the inverse test. We then need to check g of f of x is the next thing we need to check. So this time we are going to start with the g function, which is x minus 6. We start with the g function because g is written first. And we are going to insert the f function, x plus 6, in for x. There's a really quick, kind of easy one. We insert x plus 6 in for x. Again, we combine our like terms. We notice positive 6 and negative 6 just cancel out. And we are left with just a single x. So both of these, that means they're symmetric across the line y equals x. But ultimately, there's a yes or no question. So the answer to this is yes, these functions are inverses. So that's our answer to number 1. And likewise, we're doing something similar on number 2. We're going to use the same test on this problem. So if we understood what we did last Friday, most of you, I think, are pretty comfortable with this step. Again, we're just inserting negative 1/3 x minus 3 in for x right here. It's the algebra that probably a lot of you want to double check as you're working through these problems. So when we distribute the negative 3 and negative 1/3, those are just reciprocals. So negative 3 times negative 1/3 is just a positive 1x in this case, because of that x right there. And then negative 3 times negative 3 is a positive 9. Looked like for a second like those 9s might cancel, but since we have 2 positive 9s, we just combine those and we get x plus 18. So since this does not give us an end result of just an x, we don't even need to check g of f of x. We don't even need to check that one because we know that these are not inverses. So we can stop right there. All right, so I'm going to move on to number 3. So if you need to pause it now. So number 3, I would encourage you to start trying some of these on your own. Maybe pause the video, try to start it at least. If you're a little shaky on the algebra, you can kind of, I'll go over that as well. But if you want to go ahead and pause the video, pause it now, and I'm going to show the first couple of steps here in just a couple of seconds. All right, so there's the setup for the problem. We've just inserted 2x plus 14 in for x in the f function. We're going to distribute the 1/2 next. So as you can see, 1/2 times 2x, that just gives us 1x there. 1/2 times 14 is just 7. And then don't forget the -7 out here that we need to make sure we combine at the end. So the 7's cancel, and we're left with just x. So f of g of x gives us x. So we got one more part to the test. Go ahead and pause now, try that part of the problem, and I'll show you the steps in just a moment. So again, we just inserted 1/2 x minus 7 after the 2. Then we are going to distribute 2 times 1/2 x is 1x. 2 times -7 is -14. And then don't forget to drop down this positive 14 on the outside. And once again, the -14, the positive 14, they cancel, and we're left with just a single x here. So once again, we're left with an x for both f of g and g of f of x. So our answer is these are indeed inverses. I'm going to go through most of number 4 now. I'm not going to really show any steps, so go ahead and pause it. Try number 4, try it on your own, see if you can get it correct going forward. There's your work for f of g of x. Pause it again. We'll look at g of f of x in just a couple of seconds. All right, and again, there's the work for g of f of x. If something does not make sense there, just let me know, and I can help you out. And then don't forget the actual answer to this problem. It is yes, they are inverses because they passed the inverse test. All right, so number 5, I'm hoping that at this point, the setup part you guys are getting. The algebra on this one's a little bit tricky. But if you notice, we're multiplying everything in the red by 5. So since we're doing that, inside the red, we're dividing everything by 5. Sorry, that was my dog there making noise. But since we're dividing everything in red by 5, this 5 right here just cancels with this 5 right here. And we're left with just x minus 2 plus 2. And then real quickly we see the -2 and +2 cancel. And there's the setup for g of f of x. We just took that f function and substituted it in for x there. So instead of x minus 2 divided by 5, it's 5x plus 2 minus 2 divided by 5. And the +2 and the -2 are just going to cancel. So that's going to leave us with 5x on the top and a +5 on the bottom. The 5's cross out because 5 divided by 5 is 1. And we're left with just 1x. So once again, our answer is yes, these two functions are inverses. We're getting a lot on this sheet, but I know on your assignment today you'll have some that are and some that aren't. All right, moving on to number 6. Here's another one I would like for you to try on your own. It is exactly like number 5. So look at your notes for number 5. Pause the video, try this problem, and then you can check your answer. So pause now. So there's f of g of x. There's the work for f of g of x. Those 2's right there just cancel. And then we combine our like terms, we're left with just x. So now we're going to check g of f of x. So once again, we see the -7 and the +7 cancel. And then the 2 here and the 2 here cancels. So we're left with just a single x. So yes, they are inverses. All right, last one is number 7. There's only one like this, but there is one like this on your assignment. So I'm going to do this one mostly straight from the beginning. So here's the start for number 7. And as you can see, I've just inserted the square root of 8. I've just inserted it in for this x right here. So instead of x squared minus 8, it's all of the square root of x plus 8 minus 8. We talked several times yesterday about raising something to the second power and taking the square root of something. Those are just opposite operations. Those are inverse operations. So those two cancel each other out, and we're left with just x plus 8 minus 8. And then once we do that, it's pretty clear that this end result is again going to be x. So now we take g of f of x. We start with the g function, which is the square root of x plus 8. But instead of x plus 8, we're going to insert x squared minus 8 plus 8. So now this time all I've done is inserted x squared minus 8 in for that x right there. Don't try to take the square root of 8. First off, 8 is not a square root. You want to see if you have any like terms in there, and it's pretty evident. -8 plus 8 cancels out and gives us 0. And now we're just left with the square root of x squared, and we've talked a lot about that. The square root of x squared is just x. So once again, these are inverses. All right, so that is the first 7. The last couple are just slightly different. We're actually going to graph the inverses of the functions. Pause, though, if you need to get these notes. All right, so 8 and 9 are actually fairly easy. What we want to do with the line to graph the inverse of the line is pick 2 points off the line that it falls on. So that point that I picked is the point 0, 3. And pick any other point. I'm going to pick the point -2, 4. There were other options that you could have picked, and you'll ultimately get the same answer. So we talked about this yesterday. To find the inverse of a relation, we just flip-flop the x's and the y's. And that's all we've done here. So instead of the point 0, 3, we've picked the point 3, 0. And instead of the point -2, 4, we've got 4, -2. So we've just flip-flopped the x and the y. 0, 3 is transformed into 3, 0. -2, 4 is transformed into 4, -2. So graph those points. Try to make that line as straight as possible. Wasn't perfect. That was close. Just like we talked about at the beginning of class, those 2 lines are symmetrical about the line, that green dotted line, y equals x. That's a line with a slope of 1, up 1 over 1, and it crosses at the origin. Essentially, if we folded this piece right here, it would fold onto this piece right here, and this piece here would fold onto this piece there. All right, number 9, the last one, same idea. I think you have 3 points that are a little bit better outlined than I've got. It's kind of a weird one. Cubic function, so we have points 0, 0, the point 1, negative 1, and we got the point negative 1, 1. So if those are the points on the graph, to find the inverse, we're just going to flip-flop. We're going to flip-flop the points. So 0, 0. If we just flip-flop 0, 0, nothing really changes there. Still stays 0, 0. We flip-flop 1, negative 1. Becomes negative 1, positive 1. And finally, if we flip-flop negative 1, positive 1, it becomes 1, negative 1. So you graph all those points, and you'll notice those are the points that we already have graphed. It's a rare instance where this function is actually its own inverse. And basically the reason that it's its own inverse is if we fold that red line across the diagonal line y equals x, it just folds onto itself. So this is a rare occurrence where a function is its own inverse. So there's not really a whole lot to do to that problem other than list those points that we have listed. That's it. Go ahead and get the work from me if you haven't already. That's due at the end of class. Good luck.